Hello students, today we discuss the topic related to ellipse, that is chord with midpoint of an ellipse. This is the topic today we are going to discuss, chord with midpoint of ellipse. So the related theorem is like this. The equation of chord with midpoint p x1 comma y1 to the ellipse s equal to 0 is s1 is equals to s11. This is the theorem. What is given to you? Ellipse equation is given to you. x1 y1 is the midpoint of chord of the ellipse. Then we have to show that its equation is s1 is equals to s11. So consider the equation of ellipse, that is x square by a square plus y square by b square is equals to 1. This is its corresponding diagram as shown in the figure. It is the chord of the ellipse. Okay. Now its midpoint is given to you. This is the midpoint of the chord. Its coordinates are what? x1 comma y1. Now we have to find out the equation of this chord. Okay. How to do this one? How to find the equation of this chord? Now my idea is, you imagine one line that is tangent of this ellipse, that is parallel to this chord, that is parallel to this chord. How to get the slope of tangent? By differentiation of the curve. We get the slope of the curve at any point. So equate the slope of the tangent to the slope of this line. Why? Since the lines are parallel, their slopes are equal. That is why I am going to use the calculus method. So for that, I am imagining some tangent parallel to my given line. So differentiate the curve, we get the slope of the tangent to the ellipse, and I am going to equate that to slope of my chord. So substitute x1 comma y1 after getting the dy by dx, that is obtained by when you are differentiating the curve s is equals to 0, we get the slope of the required chord. After getting the slope, you have the point on the curve. Once if you know the point slope, you can easily write the equation of the line. That is the basic idea of my theorem. So differentiate with respect to x. Then what is the derivative of x square? 2x. Derivative of y square is what? 2y. That is why 2x plus 2x by a square plus 2y y dash by b square is equal to 0. We are differentiating with respect to x, that is why derivative of y square is 2y y dash by b square equal to 0. From that you can calculate y dash, that is equal to minus of 2x by a square by 2y by b square, that is nothing but minus b square x by a square y. It is the slope of tangent at any point of the ellipse. If it is equal to, if the tangent is parallel to my line, then just I substitute the x1 comma y1 here itself, that becomes the slope of tangent. Slope of the tangent, that is slope of the tangent, that is equal to the slope of my chord. So if the tangent is parallel to our chord, we get slope of the required line is minus b square x1 by a square y1. This is the slope of the chord having the midpoint at x1 comma y1. So you know the point on the line and having slope minus b square x1 by a square y1. So can you write the equation or not? By using the formula y minus y1 is equals to m into x minus x1. So y minus y1 equal to, what is m value? Minus b square x1 by a square y1 into x minus x1. So on simplifying, you just cross multiply. We get y minus y1 times of a square y1 is equal to minus b square xx1 plus b square x1 square. So on simplifying this one, we get a square y1 minus a square y1 square is equal to minus b square xx1 plus b square x1 square. Take a square y1 to right, y1 square to right side and minus b square xx1 to the left side. We get b square xx1 plus a square yy1 is equal to a square y1 square plus b square x1 square. Dividing on both sides by a square b square, we get xx1 by a square plus yy1 by b square, that is equal to x1 square by a square plus y1 square by b square. Now subtract 1 from LHS and RHS, we get xx1 by a square plus yy1 by b square minus 1 equal to xx1 by a square plus yy1 by b square minus 1. Now what is the left hand side value? This is the notation of S1. What is the right hand side value? This is the notation of S11. So S1 is equals to S11. This is the equation of chord with midpoint x1 comma y1 to the ellipse. S is equals to 0. Here we have used the calculus method. If you want to use directly the geometrical method, you use the formula S1 plus S2 is equals to S12. Here on simplifying, you replace x1 plus x2 by 2 by x3 comma y3. Now then write the S3 is equal to S33, or if your midpoint is x1 y1, you may take it as S1 is equals to S11. Understand? So we are using the calculus method here. The only idea is you have to imagine some tangent which is parallel to our chord, and from that you write the slope of the chord, that is obtained m. Once if you know the slope and point, you can write the equation of the chord with midpoint. That equation is S1 is equals to S11. Okay, with the help of this formula, we have to do some problems related to this one. Now see this problem. If the midpoint of chord of ellipse x square by 16 plus y square by 25 equal to 1 is 0 comma 3, then find the length of the chord. So what you have to find out here? We have to find out the length of the chord of the ellipse, whose midpoint is what? 0 comma 3. We have midpoint of chord. From the previous theorem, can you write the equation of chord or not? We can easily write the equation of the chord by using the formula S1 is equal to S11. Once if you know the chord equation and ellipse equation, it is easy to find the point of intersection. Once if you know the point of intersection, these are the ends of the chord. Once if you know the ends of chord, can you find its length or not? It is easy to find out the length of the chord by the formula root of x1 minus x2 whole square plus y1 minus y2 whole square, where x1 y1 and x2 y2 are their points of intersection. So only the logic behind the problem is write S1 is equal to S11 and solve with the ellipse. We get the point of intersections and hence find the length of the chord joining of these 2 points. Okay. So the equation of chord with midpoint x1 comma y1, here the S1 x1 comma y1 is 0 comma 3 is what? S1 is equals to S11. That is nothing but 0 into x by 16 plus 3 into y by 25 minus 1 is equal to 0 into 0 plus 9 by 25 minus 1. That is S1 is equals to S11. What is S1? xx1 by a square plus yy1 by b square minus 1. S11 is nothing but x1 square by a square plus y1 square by b square minus 1. So you just substitute the point on the ellipse, we obtain S11. S1 is obtained by x square by xx1, y square by yy1. You have tried. So 0 plus 3y by 25 minus 1 is equal to 0 plus 9 by 25 minus 1. Cancel out minus 1 on both sides and simplify. We get y is equals to 3. What is this y equal to 3? This is the chord equation having midpoint 0 comma 3. You just simply solve this line equation with the curve x square by 16 plus y square by 25 equal to 1. We get the extremities of the chord. Once if you know the extremities of chord, you can easily find the length of the chord. Understand? So x square by 16 is equal to 1 minus 9 by 25 by solve with y is equals to 3 to the curve. Now what is the value x square by 16? X square by 16 is equals to 9 by 16 by 25, that is x square is equal to 16 by 5 whole square, 16 16s, okay, 16 into 16, that is nothing but 16 square by 5. From the simplification we get x is equal to plus or minus 16 by 5. Okay, when x equal to plus or minus 16 by 5, then the value of y is 3, which is fixed. Y is 3, x is plus or minus 16 by 5. So what are their points of intersection? their points of intersections are 16 by 5 comma minus 16 by 5 comma 3. So these are the extremities of our chord. Once if you know the extremities of chord, can you find its length or not? Just to find the distance between the 2 points, that is nothing but 32 by 5, because y coordinates are fixed. So the distance is nothing but 16 by 5 plus 16 by 5, that is nothing but 32 by 5. Length of the chord is 32 by 5 units. So this is the way to find out the length of the chord when midpoint of the chord is given to you. Understand? So in this manner we can find the length of the chord. You write the S1 is equal to S11 and solve with the curve. We get the extremities of chord and hence find the length of the chord. Okay. Now let us see the another problem related to the same topic. This is the problem. Tangents are drawn from 3, 2 to the ellipse. Tangents are drawn from 3, 2 to the ellipse. X square plus 4y square is equals to 9. Find the equation of their chord of contact and midpoint of the chord of contact. Here there are two concepts involved in this problem. First one is find out the equation of the chord of contact, and second one is you have to find out the midpoint of the chord of contact. These are the two things. So your point must and should be outside, then only your chord of contact is exist. What is the equation of chord of contact? All of you know that S1 is equals to 0. Chord of contact of Px1 comma y1 with respect to the ellipse or circle or hyperbola, whatever it may be, that is equation is S1 is equals to 0. Let us see how to solve this problem. This is the given ellipse as shown in the figure. X square plus 4y square is equals to 9. Now this is your external point, because the chord of contact is defined for the external point. This is 3, 2. So draw the two tangents drawn from that point. What is this point here? R, say its coordinates are what? 3, 2. Now we draw the tangents through R to the ellipse as shown in the figure. This is one tangent. This is the another tangent. Touches the ellipse at the points as shown in the figure. One point is at P, other point is at Q as shown in this figure. Now these are the 2 points of contacts of tangents drawn from R3, 2 to the ellipse. The line joining of PQ is what? Chord of contact. That is the definition of the chord of contact itself. So PQ is the chord joining of the 2 points as shown in the figure. This is the chord of contact. What is the equation of chord of contact? S1 is equals to 0. Now after getting the equation of PQ, also we have to find out this midpoint. This midpoint. It is the midpoint of the chord as shown in the figure. We have to find out. This is M, say. So by just writing S1 is equal to 0, we get the midpoint of the chord. Once if you know the chord equation and ellipse equation from the previous question, you solve the chord equation with the ellipse equation, we get their points of intersections. Once if you know their point of intersections, you can easily find the midpoint of the chord. But I am not going to use that method. That is that finding the point of intersections. Without finding the point of intersections, I am going to find there its midpoint. Understand? For that I am going to use the calculus method. How to do that problem? Let us see. First we have to find the equation of chord of contact. Equation of chord of contact is what? S1 is equals to 0. First of all I am going to write the equation of chord of contact. That is S1 is equal to 0. That is what? Xx1 plus 4 times of yy1 minus 9 is equals to 0. That is 3 into x plus 4y into 2 minus 9 equal to 0. That is 3x plus 8y minus 9 equal to 0 is the equation of the chord of contact. So once if you know the chord of contact equation, the general procedure is you have to solve the chord with ellipse. You get the 2 points P and Q, and then you are going to find their midpoint. But I am not interested to find the point of intersections. To get the shortcut method, I am going to use the calculus method. What is the calculus method here? I am going to imagine some tangent parallel to this chord. I am going to imagine some tangent to the ellipse parallel to this chord. When the lines are parallel, their slopes must and should be equal. That is why I am going to differentiate the ellipse and we get the slope y dash. I am going to equate that slope y dash to the slope of my line. That is what 3x plus 8y minus 9 equal to 0. From that, we obtain some relation between x and y. By equating the slope of the curve to the slope of my line, we obtain some relation between x and y. I am going to solve that relation to the chord equation, that is 3x plus 8y minus 9 equal to 0 as shown in the figure. We obtain immediately the midpoint of the chord. That is the logic of the problem by using the calculus method. What is the logic here? You have to differentiate the curve first and then find y dash. Equate that y dash to the slope of the line. We obtain some relation between x and y. Solve that relation to the line equation 1. We obtain the midpoint of chord of the ellipse. This is the logic. Understand? So for that I am going to differentiate the curve. Differentiate x square plus 4y square equal to 9 with respect to x. We get 2x plus 8y y dash is equal to 0. From that we obtain y dash is equals to minus x by 4y. Okay, because the 2x is equals to minus 8y y dash, 2 gets cancelled out 4 times by 8. 2x plus 8y y dash equal to 0 implies x is equal to minus 4y y dash. Therefore y dash is equal to minus x by 4y. I am going to equate that minus x by 4y to the slope of line 1, that is chord of contact, equal to minus 3 by 8. So x by 4y is equals to 3 by 8. Cancel out the minus. From that you can easily write the value of x, that is equals to 3 by 2 times of y. This is the relation between x and y. Okay, this is obtained the relation. We have to solve this obtained relation to the chord. Immediately we obtain the midpoint of chord. In this process we are not finding the points of intersection and the midpoint, and hence through the midpoint you just write the slope y dash and equate to the slope of line. Immediately we get some relation. Solve the relation to the line equation, we obtain midpoint. By solving the line equation with the second degree equation, it is difficult than solving the two linear equations. That is why I am going to choose this method to find the midpoint of the chord. So by simply solving these two equations, we obtain 9 by 2y plus 8y is equals to 9, because x is equals to 3 by 2y. 3 3s are 9 by 2y plus 8y is equals to 9, and hence 25 by 2y is equals to 9 implies y is equals to 18 by 25. Substitute 18 by 25 in equation number 2. We obtain x value. That is 3 by 2 times of 18 by 25. That is nothing but 27 by 25. You have x and y. The coordinates of midpoint of the chord are simply 25 by 7 comma 18 by 25. This is the way to find out the midpoint of the chord. So the first bit is chord of contact. Chord of contact is S1 equal to 0. The chord of contact becomes chord of the ellipse. It is a chord. Actually, we have to find out the midpoint of the chord. For that, I am using the calculus method. In this method, you just find the derivative of the curve, equate that slope to the line. Here the line is what? Chord of contact. So we obtain some relation between x and y, solve that relation to the chord, immediately we obtain the midpoint of the chord. Or you can find the points of intersections and then find the midpoint. It takes some lot of time than this method. Okay, let us see one more problem related to the same concept. Dear students, see the question. This is the problem. Find the locus of midpoint of focal chords of ellipse x square by a square plus y square by b square is equals to 1. This is the question. We have to find out the locus of midpoint of focal chords of ellipse. How many focal chords are exist to an ellipse? Infinite number of focal chords. What is meant by focal chord? Focal chord is nothing but a chord which is passing through the focus. There are two foci. So any chord passing through any focus is called focal chord of the ellipse. We are going to find out the locus of midpoint of focal chords of ellipse. Suppose a chord passing through focus, you have to collect its midpoint. Collect all such type of midpoints, you get some locus. That is we are going to find out here. So Consider the equation of ellipse, that is x square by a square plus y square by b square is equals to 1. This is the diagram related to the given ellipse. X square by a square plus y square by b square is equal to 1 as shown in the figure. This is the axis of the ellipse. This is its focus, one of the focus of the ellipse. If a chord passing through focus, that is called focal chord of the ellipse. This is the corresponding focus. This is focal chord. A chord which is passing through focus is called what? Focal chord. This is the focal chord, one of the focal chord. Now this is the midpoint of the chord as shown in the figure. Let P be the midpoint of the focal chord as shown in the figure. You can draw infinite number of focal chords. So we obtain infinite number of midpoints of their corresponding chords. These are focal chords. We collect all those midpoints. We get some locus, that is we are going to find out here. So this is the meaning of the question. Let Px1 comma y1 be the midpoint of some focal chord of the given ellipse. X square by a square plus y square by b square is equal to 1. Can you write the equation of its chord or not? You can easily write its equation by the theorem. S1 is equals to S11. So the equation of the chord midpoint x1 comma y1 to this ellipse is S1 is equals to S11. That is what? Xx1 by a square plus y by 1 by b square minus 1 is equals to x1 square by a square plus y1 square by b square minus 1. This is the chord with midpoint. What is the speciality of this chord? This chord is always passing through my focus from the given condition. What is the condition here? The chord passing through focus. So x comma y are replaced by ae comma 0. Or you may put minus ae comma 0 also. So substitute ae comma 0. It is passing through the point ae comma 0 since it is focal chord. So by substituting ae comma 0 in the above equation, ae x1 by a square plus 0 minus 1 is equals to x1 square by a square plus y1 square by b square minus 1. Cancel out minus 1 on both sides. We obtain x1 square by a square plus y1 square by b square is equals to ae x1 by a square. You can cancel out aa. We get x1 square by a square plus y1 square by b square is equals to ex1 by a. So this is the condition for all x1 comma y1. We can write the locus of x1 comma y1. We obtain by replacing x1 by x and y1 by y. We get the required locus. So the required locus is x square by a square plus y square by b square is equals to ex by a, by cancelling a from numerator and denominator. This is the way to find out the locus of midpoint of chords of the ellipse. In this manner, with the help of the chord with midpoint, that is S1 is equals to S11, we can do some of the problems. Understand? This is the concept. Thank you very much.